Hello, well, our lives. And is the screen visible to you? Can anybody just properly confirm whether I'm audible and is the screen visible to you? Confirm. All people. Okay. Thank you. So before starting, um, okay, before starting, let me know, do you have any question or any doubts from the previous? If you have any doubt, any question, without hesitation, you can ask or problem. If you have any doubt or any question from previous session or ask, or else we can today's problem. For starting, tell me. Do you have any doubt or any question for previous session, or else we can start with the our question. Okay. Okay. As for okay. So tell me first, what is the submission date of assignment two? Submission for assignment. Ah, okay. Others. R2 to R2 is okay. So now tell me your doubt. Go and unmute you. Okay, no problem. So point is that then what isometric. It's a distance. That means one more thing before writing, I says that time unmute your because today there is some issue coming. Well, property tell me question rigid motion. Rigid motion, distance preserving. That is, suppose F is an R2 to R2 motion. Suppose that is uh, distance between Fx and Fy, x minus. What by we mean a rigid. That is and this is same as saying that currently x is to x. One more thing is that sorry do and plus additional definition f0. Okay, either you can say this two or you can say this. So this is by what. So now in that question, um, so in that question, there is a counter example which shows that f of s1 is not equal to 1. So yeah, so that is the one thing I must sorry, one thing I must say is that sir did not took any extra condition like f0 equal to 0. So only this is the only region, the only there is nothing equivalent if only distance are preserved and if is of course if is continuous. Of course if so there's the I have this. So any next doubt or next question, let me know. If you have any more doubt, please let me know. Okay, I hope that there is doubt from previous session. Okay, in case if you have any doubt from previous sessions or this session itself, you can ask, you can stop and ask me. Okay. Okay. So today we shall start with the problems, of course. So today we shall start problems from the continuities itself. Okay. So okay, can anybody please confirm in the 2 or 3 days ago, Sastri sir took some live session over YouTube. Can anybody please confirm that what he has explained in the session? other than discussion with you. Can any okay. Okay, it seems as nobody is at that session. Well, so let's get back to our original business for today. So now so there are some, so let me write it down. So first question is event. Okay, thank okay. First question. First question is that, so suppose let x1 d1 and x2 d2, then we know that on the product space we can any metric we have seen the first session of x1 x of correct, so that xn comma yn this sequence 1 comma if and so this is the question. So first so let me read it out the question first. So there are two metric space x1 d1 and x, and so on the Cartesian product we can give a, as the max of distance between. Now the question is that under the product metric, so there is a product metric. Now the question is that suppose there is sequence xn comma y inside x1 cross x, and suppose the sequence converges to some point x. This will hold if and only if the each pair, sorry, the each component converges to the corresponding. That is xn goes to a, yn goes to. So yeah, so this is the thing and try to prove it. So so let me give the hint. So in order to prove this thing, you only the definition of convert. Nothing extra is. I mean, the point is, if you just write down line by line, I couldn't. I want you to do it by self now. So please try to solve this question right now. Let me know. Are you able to solve it? Or please try to solve it by yourself first. And if you are done, then please If you are done, please let me know. Please try to solve it by yourself. You only of what of metric space, sorry, of the continuity in the matrix. That is what only need a extra by yourself first. Anybody able to solve this problem? Or if you have doubt at how to start, you don't be silent. Okay. Okay, so then plain. Okay. So 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 look. So the since it is given that the sequence xn comma yn goes to x comma y. So this implies what? If we choose any epsilon greater than 0, by definition of the convergence, there exists some n naught such that the distance between the points in the sequence and point of convergence, this will less than epsilon for all n greater than equal to n naught, right? So this is what? This is only definition. This is only definition. Okay, nothing more than that. So next, now what do you know that p of xn comma y comma xy? This is by definition. This is also equal to max of d1 of xn comma x and d of yn y. Correct. So definition. So this implies what? This implies max of 1 of n comma x comma 2 of yn comma y. This thing is less than epsilon. And of course, max of something, this is always greater than 1 of xn comma x and of course d2 of yn, right? So this implies what? Implies one of xn comma x less than epsilon for all n greater than n. And also Q of yn comma y less than epsilon for all n. So this tells what? So first equation tells that the sequence xn converges to x, and the second equation, the sequence yn converges to y. So this is one side. So what is the side? This tells that the sequence xn comma yn goes to x comma y, then xn goes to x and yn converges. So first let me know, do you understand this argument only? Please let me know, do you understand the argument from? Okay. Okay, before going to the second part of the argument, there is some internet issue. So I shall close the meeting, and now I shall leave them. Okay. Well, can anybody just confirm whether I'm okay? Thanks. Okay. So now, okay. So the first part of this question is clear. Now let's go for the second part. So now, suppose. So what is the assumption? Suppose. So now, so let the sequence xn goes to x and yn goes to, okay. So um so this implies what? So now choose an epsilon greater than 0. So by definition of convergence sequence, there exist two natural numbers n1 n2. They are naturals. Does that one of xn comma x, this is less than epsilon for all n greater than equal to, and d2 of yn y, this is also less than epsilon for all n greater to n2. Okay. Now take n3 equal to max of n1 comma. So then, so this implies that x1 comma x, this is an epsilon for all n greater than equal to 3, and d2 of yn y less than epsilon for 3. Okay. Now what we need to do, we need to consider d of then comma x comma y. We need to check this thing is not right. So for that, what this thing is by definition equal to max of d1 of, sorry, sorry, there is a typo, max of xn comma y. So this will be max of d1 comma xn comma x comma d2 of yn comma y. Now we have observed that each of these two, this thing is individual less than epsilon, so this thing is individual less than epsilon. The whole thing will less than epsilon for all n greater than equal to n3. So this tells that this distance d of xn comma yn comma x comma y. This whole distance less than epsilon for all n greater than equal to 3. So this implies what? This implies the sequence xn comma yn goes to y. So this is the part of this. Can anybody confirm whether properly or okay, thanks. Okay. So well, so now okay. One more thing I should mention is that observe that observe that so here we have choose the so here we have choose only the product metric as the max of this thing. Okay, instead of we take max, we can also take um, um over of 1 square plus d square. One can also take d1 power p plus d2 power p whole to the power 1 by p. These are all valid metric on the capital A. Okay, and also the same statement of this question hold for other metric also. One can individually check it, but there are some equivalence thing we see into possible session that if it is sufficient to check on the that this particular statement of this question only for one given metric, then it automatically gets satisfied in that is the thing I want. So now there is a question uh, so that any so that any plane in R3 is a closed set. So what is the question? Show that any plane in R3 is a closed set. So try to solve it yourself. So first of all, closed set means complement is open, but don't try to go with that direction. It will be very much. So what we will do instead? So instead, you can try. Um, yeah. So instead, you can try to show the closeness by using the sequential criteria. That is, if you consider point in the plane, consider sequence in the plane which converges to some point. Now then try to show that convert point of convergence also a point in that closed plane itself. Okay. So try to approach it by yours. Try to first by yourself. I shall be back after two. So anybody is to actually what actually Can you, so what is need to show for sequence x call the and sequence call x. So well, so one more hint that follows. Any plane in Rn but x plus by plus c. So this is an equation. So now you can fix some and then try to now please take your time. Think about it. Once yeah, correct. Uh, I said and if you take the that, yeah, very much correct. Yeah, so there is nothing. So what you practically what you have actually used, correct? That is this function. I mean, apart from answering the question, for a thing, this list that an continuous function, right? So that's why you so so now suppose f is a function Rn2, so that set all those x, so that the set all those x belongs to Rn, that if the closed set. So what I need to, all those the closed, and of course if function Rn to Rn. So now what to do? Now what to do? Here also, of course, you need to the criteria of, and also given the fact that if, so what you will do? Please. Any idea how to close this problem? Oh, here, of course, you need to do what? So, suppose that x, okay, yeah, please.
Uh, as n tends to infinity, we have limit of xn is equal to x. Then by definition of a continuity of f, we can say that limit f of xn is equal to f of limit of xn.
Correct,
Then limit of f of xn is equal to limit of d, which is nothing but d again.
correct,
So d can be rewritten as f of limit of xn, which is nothing but f of x. So f of x is equal to d,
correct,
and it is closed.
correct. Very much. So, I mean, what observe is, and taking the side it. So that is the thing. So it only basically, okay. So So this is correct. So now, okay. So, this previous question can be modified in the follows. So suppose f is a function from, and of course here if I did not, then that all x belongs to x and fix some y not y, show that all x belongs closed. So what is the question? Question is that suppose f is a function of y and suppose fix some y naught. Now show that from all those x belong to the fx, what is the closed serial? How to not it is try to isolate. Let's try to Well, so now solve this question. You ready? Yeah, please tell.
Here we have the limit of xn tends to x and f of xn is equal to y naught. Then we have to prove f of x is equal to y naught. Then we can prove in a similar fashion as in the previous problem where we can put simply y naught in in the in the place of d.
Wait. Can you the argument again?
So that is we have to show there exists a sequence xn that converges to point x. That is, let me consider that the limit of xn tends to x and f of xn is equal to y naught. Then we have to prove that f of x is equal to y naught. This is the same case that we have done in the previous question that for d.
Yes, correct.
So limit of xn is equal to y naught and hence just interchanging f of limit of xn is equal to limit of f of xn, we can arrive at f of x is equal to y naught.
Correct. Absolutely. I hope, yeah. So I'm not writing that. How do you get? I'm moving for the next. Next question is for that of orthogonal matrix. What you need to that's set of the orthogonal matrix. So before starting this problem, so it is in all matrix R. So what is the metric there? The metric is the usual product metric, or you can consider the filter metric. And so I mean, in R you can consider of R to the so you can consider. So now tell me or how you can able to just observe. able to figure out how to.
Uh, so likewise, can we define any matrix AK such that limit of AK is equal to A, then A belongs to the set of all orthogonal matrices, and take instead of f of something, we can have A transpose into A is equal to I. So let me consider a sequence of orthogonal matrix AK such that AK tends to A as K tends to infinity. Since AK is orthogonal, we can have AK transpose, uh, or in the similar fashion, A into AK transpose is equal to I for all K. So taking limit, I can have limit of AK into AK transpose is nothing but limit of I, which is equal to I again. And transpose operation is continuous. So I can have limit of product of AK transpose and AK is equal to limit of no product of limit of AK and limit of AK transpose, which again is A into A transpose, which is I. So A belongs to the set of orthogonal matrix N, O of N.
So this way is correct. But so now, so in the previous problem also, so these problems you have explained. Other than this, it can be explained. So this given set nothing but inverse of single, correct? And have seen last say Hilton. Hilton is closed. Hilton set binary is closed. If is continuous, is function is continuous. First image, first image, singleton is always closed. The inverse, that is if in. Understand this? So all the time you don't, because in some situation possibility. For this second question itself, also for the second question, uh, this set of orthogonal set, but this is nothing but if inverse of I, close singleton set. Directly you can now short set of orthogonal. You understand my point?
Yes.
So, following question. So, something. So, for their first call is that suppose ABS absolute every x comma d is a matrix. So, let x this holds. There exists a sequence A. There is specific difference possible to criteria of to keep that. So now we are going to make some new function follows. So define to be infimum of what is this? That is, suppose we have some and this our we are now considering choosing we are now considering all possible from and suppose this is now we are choosing all possible x and we are choosing so I mean so just by geometry or perpendicular. So this is our norm can be so this is the definition it and now so first question is that a equal to z if and on try to prove it or you I mean of course you need about well before this let me know are you
Theory, some
okay from problem try to show just from and one more thing is that that's why I already tried what you need Well, problem. Okay, so let me. So dx equals as what? So guys, here exists a sequence that x as n. So first confirm can by this infimum able to get states of a n comma x here. So basically, for suppose a is a subsystem, suppose a s there exists x, does that set a point the c converge L. So are you now recall? Are able to? So in reality, you have solved it, no problem. Problem is ACS and A possible to get a sequence. Uh, Now point observe that since of a comma exists element info. So of course this comma x epsilon for but the set of points of n unable to.
Yes, sir.
So, what? So this what is also so closed. So this is equal then. So this is one fact one can. So okay. So till now understand actual. Well, so okay. So so okay. So before starting the next question, can any What does it? What is it?
If every point of the set is either contained in the subset or a limit point of the subset, then we call the set as dense set.
Absolutely correct. Ah, so there is one more thing. So there is for any suppose E be the dense third equivalent definition. So these are the three. First one is what for any open. So you need to use all these three might not be. So suppose suppose uh set subset f y if both exist so that so there are two sorry I mean for contrast f and contrast now we need to show the equal function. So how to approach definition think about So can you tell, or sorry, were able to solve? So anybody able to solve this problem?
For D dense D closure is whole X. Can we use the fact that f of closure of A is contained in closure of f of A for any
Right, you,
A?
yes, yes, you can use the solve it. Others. Oh well. Okay. So Now take x. Now since x is, there exists a sequence xn does that. Now since xn is n goes to x size of x was a by content. So then by s of limit. Possible to, so so xn of x, then the unique. So this is the, so okay. So there is just thing I should, of course you have a set of rationals. We will prove it, but not today. Later we shall prove, because this proof. So this, now so let f not to, so that x all x some lambda. So important to show, if is a additive continuum, additive f of y is equal, such a function for some, how to, so try to, so okay. So the first hint is that try to for in, that is, so that x x, and for if there is some lambda, lambda, first try to prove that at least for this there is for this only using identity first try. If first step, please take out time, try to solve. Please try to solve it. Oh, for so only first try to show happen for only for integer. First try to do. And of course, you need to find the lambda. That is first.
Take both x and y equal to 0 and use f is additive continuous. We get f of 0 equal to 0.
Yes, correct. And that's good. Okay, so instead of directly showing that for all integers is happening, first try to show that at least for natural numbers, this thing is true. The effects of lambda x, the natural first try to prove.
Next, if f of 0 equal to 0, we got. So 0 equal to, if we take like n minus n for any natural number, then using additive continuous property, f of n plus f of minus n equal to f of 0, which is equal to 0. Then f of n equal to minus of f of minus n.
So what we have done is that the answer and the same answer we have can have that negative natural. So only now it is sufficient so that this only to show that this thing equal to lambda of n So this is what only need to, right? Now try to use the additivity. Good try. Now try to use the additivity. So I mean, so
Okay,
yeah,
we if we reverse minus n, f of minus n equal to minus of f of n,
I mean,
like f of 1 n times we get like
correct. So
n
that is
into,
equal to n of f1, right?
yes sir.
Yeah, correct. Very good. So what she explains is that, so f of n can be written as, f of n is nothing but f of 1 plus 1 1, and this is nothing but f of n. F of n is equal to n of
Like
f1.
this, if we prove for integers, we get
Correct.
lambda as f of 1.
Correct. And this one, yeah, right. Good observation. So this one is lambda, and in that case, f of minus n is equal to minus f of n. So that will be minus of 1. So now we can club this minus. So altogether we get that f of x equal to f of 1 times of x, where x will to z. For natural numbers, this one is true now. For natural number, this, now we need to show uh, same equation is true for the for what, for rational number. So for rational numbers, what we need to take? So x equal to p by q, and of course you can assume q is greater than g, without, any. Now using again additivity, try to show that f of x equal, using additivity, try to show. Whatever you tried, it is correct. Now same trick, try to show that, the same trick try to show, if you now,
Let x equal to p by q. So f of p by q is equal to f of 1 by q plus 1 by q p times f of 1 by q plus 1 by q plus 1 by q.
first of
Uh,
first of all we have choose to be greater than, right? Okay, so in order to use your argument, assume p is greater than, correct, otherwise 1 by q, right? 1 by q plus, so of course this will be times, so times of f of, then good try, but then tell how to, how you will get the f, or instead going in this direction, you can go to the take q, and now so this says that, right, now you can apply f in equation, and now are you able to out of this x equal to p by q, you can assume, and from this equation p is equal to qx, are you able to manage to applying, after applying f, are you able to came from
Writing q times f of x plus x plus x. Can we do that?
x. Then what is f of p? Observe that we have already that f of x for x, right? F of p is what? F of p is equal to times f of 1. These things f of x by q.
Yes, sir.
So, and this one is nothing. So, till rational. Now we need to show that this holds for all real. So now what we so now so for the, let's go to the previous problem. The previous what we have seen. Suppose there are two functions and g. Suppose there are degree n set full domain. So now we can use this for our problem also. Am I correct? What I'm trying to say? Okay. So now since q is dense, so this is x is equal to x of f of 1 for all x. So yeah, so this is the argument. How do you build?
For irrationals also, the irrationals are dense enough and hence. Yes, okay.
Did not use anything like irrational density. They use that rationals are dense. Are okay. Since the function f of x equal x multiplied on the rationals for the capital real line, and we are not using any rationals.
Okay, sir.
But anyway, irrational. What do I not use? So It of all invertible matrix. Of all invertible. For that, for style. So for that, what you need to do? You need to choose a function, choose some function in such a way that the inverse image of the function of some open set, open in name. When you need to choose some function f, so to choose some function f from M and R to some place such that f inverse of something equal to this inverse. So this is what you need. Now try to figure out some function from M and R somewhere. You understand what I'm trying to understand. Does that if inverse of some subset able to choose what function you
Can it be the determinant?
So general linear space, like GLNFR, if we can take.
LNR. This is the GLN. Need to if in something is GLNR. Not take and then if of and when, that's why so here what Raul has said. R minus 0 is equal to R and R minus will open. So continuous of M and R. So this is the so is it clear to everybody?
Yes.
So now the next question is, okay, okay. So now I want to know that how many of you have the concept of compactness? So there is one concept, space and both. How many of you? How many of you? So okay, so starting the problem. And how many of you? How many of you have read the compactness in previous semester of um? How many of you? So you have done compactness in, or you have done compact other thing, or in which course you have done this
Metric space.
okay, okay. So let's proceed with the definition. So what is the definition you have read in metric? Same definition. So, but for sake, let me write down. So let x because what's that? By open cover from x in collection of open subsets x does that does that. So what is the definition? So suppose X a topological space by open cover U is equal to U of X. We collection of open subset U X as X. This is what I mean. Open. Okay. And X is said compact. Every open has finite subcover. That is, here exists alpha 1 alpha n such that X is union of. So that means only finite part of the alphas, the end. So this is the definition. So this is the open curve. The finite sum. Well, I understand that. And I mean, of course, in case of reanalysis, the metric as well, you have some intuition. But in topological space, it is very hard to determine some compact or not in general. Okay, so that's why there are some process of determining whether some given not. But in general, it is very for topological space. So okay, so before giving example, I want to know one thing. Do you heard about cofinite topology, or are you able to remember cofinite topology? What does or I mean how this topology cofinite? No, it is not. It is cofinite. Ah, okay. That's I mean, okay. You should clearly tell that it is not feasible. That's okay. Understand. Whenever you are unable to understand something, please unmute you. Just tell. Cofinite. So cofinite topology. Anybody able to remember the definition of this?
Any subset of X is empty or its complement is finite.
Correct. And that is how the topology is defined. All those subset of X that see. So that is the co. So just after definition of compactness, first question is that so that any cofinite topological space any cofinite topological try to show. Of course, for what for that what you need to choose an open. So that is what you need to do. So choose. So let U alpha an open cover of X topological. Now we need to show that there is a okay. Yes, it is and there is try to at least try to show or I will So, um, so take x belongs to. So this implies what x belongs to, and this x equal to union. So this x belongs to E naught. What's some alpha?
Yes.
So actually there is nothing. So choose alpha naught, and in that case is equal for naught is x minus e, right? Because u of is open cover, so we are not. So let this contains x1 xn. So now we can say that this x1 belongs to e alpha 1, x belongs to n belongs for some alpha, correct? Because x equal x we as okay. So 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 we choose some alpha naught, and then x minus u alpha naught is open. So sorry, u alpha naught finite, so x minus u alpha. So we choose some points x1 x2 xn, and x1 belongs to u alpha 1, u alpha 2, u alpha n we can take because x equal to u. So now we can say that x equal to, so finite sum, cofinite. So this is that. Are you able to, are you able to understand?
Yes, clear, sir.
So it is 9. So we stop here. Okay? You can ask me, or you can ask from, and from next session we shall first go with problems, and sorry, first go with the theory part, then start. Or in the meantime, if you have any, then you can directly email to the input announcement directly. Thanks. So I'm leaving.